So the goal in this video is to teach you how to deal with compound statements in math. So and or statements. This ties in a lot with logic and reasoning as well. So we'll talk about that. Quick little activators, things to remember from the last um, topic B. So we're in a new topic now. We're in topic C. This is compound inequalities and compound statements. So we're going to start by, getting the variable to be on one side. So we can go ahead and subtract 3 x's from each side. And if we do that, it cancels out that one. And it leaves me with -4 is equal to 2x plus 20. Then I can go ahead and subtract the 20 from each side. And I get -24 is equal to 2x. Divide both sides by 2. And x will be -12. To write that in set notation, you just go ahead and use your curly bracket, write -12, and curly bracket. Okay. In the next activator, we're going to be tackling, inequality symbol. So it's the same problem, but with inequality. So guess what? We follow the same steps. We're going to start by subtracting 3x from both sides. So we end up with -4 is greater than 2x plus 20. Now you could start this problem by subtracting 5x, but then you'll have a negative coefficient in front of the x, and don't forget to flip your symbol if you do that, this symbol right here. So don't forget to do that if you choose to subtract 5x instead of subtracting 3x. Next, I'm going to go ahead and subtract 20 from both sides. So we get -24 is greater than 2x. And in my last step here, I will divide both sides by 2. Now, you might say, well, Mr. Writing, that's going to give me a negative answer, so my symbol should flip, right? No. It's if you negate both sides. So if you divide both sides by negative, then your symbol flips. Okay, so now what do I do with this information? Well, first off, we can graph it on a number line. So we're going to say, you always say this with the variable first. So it's not -12 is greater than x. You say x first. It's x is less than -12. That's how you say it. So if I do that up here, x is less than -12. It's not equal to, so it's an open circle, and it's going to go to the left. So again, x is less than -12, and it's open, an open circle, because it's not equal to. If it had been equal to, then it would be a closed circle. All right. Let's look at the next example. So same idea, but this time we have to distribute first. Let's see what comes out of that. So we get 3x minus 15. And on the other side, we have 3x minus 5. Now, if this was an equation, I don't like the way I wrote that. If this was an equation, we would say right away that that's going to be no solution, right? Because we would notice that, hey, I have something different on each side after I cancel out the x's, right? So that would be no solution, again, if this was an equation. But we have to actually finish it out if it's an inequality. So if I subtract 3x from both sides here, I get -5 is greater than -15. And guess what? That is a true statement. So what does that mean? That is true. It means we're going to get all real numbers. So again, our variables canceled out, and what we were left with is a true statement. So we get all real numbers. That on the number line is the entire number line. You would shade the entire number line. And in set notation, you could just write all real numbers. Okay. All right, little introduction into compound statements. And versus or. So now what we're going to do is we're going to take like 2 of those equations or 2 of those inequalities that we just did and put them together. Okay, so with and statements, it's like I'm going to the movies and then going to my friend's house for a sleepover. If I say and, both of those things have to be true for that statement to be true. So if I tell my parents, hey, I'm going to go to the movies, then sleep at Ashley's house, I have to do that or I lied to my parents. Okay, so I can't go to the movies and then sleep over someone else's house because that's a lie. It's you have to do both of those things for it to be a true statement. So with and statements, both part of the statement have to be true. If I change that to an or statement, hey mom, I'm gonna go to the movies, or you know what, we're just gonna sleep over Ashley's. I'm not really sure which one we're doing, but we're gonna do one of those two. Then it's a true statement as long as I do one of those things. If I do both, it's actually also okay. So with an or statement, as long as one of the parts is true, then I didn't lie. So both parts can be true, but at least one of them has to be true. So if I don't go to the movies and I don't sleep over my friend's house, I told a lie. So for example, uh, mom, I'm going to clean my room or I'm going to go outside and play. So if I go outside and play and I don't clean my room, that's fine. As long as one part of that statement is true, it's not considered to be untrue or a lie. In math, that looks like this. The answer is either no solution or x equals 3. So if I said that and the answer is x equals 3, I'm good. If the answer is no solution, I'm good. If the answer is x equals 10, I'm not good because I said it would be either x equals 3 or no solution. The next one, the answer is no solution and x equals 3. It can't be both of those things, right? If it's no solution, then that means nothing works. So it can't be no solution and x equals 3. That would be a not true statement. So that's where that comes into play, the and versus or, right? For an or statement, one part has to be true. So let's just jot that down real quick. For an and statement, everything must be true. For an or statement, only one part needs to be true. But it could also be multiple parts, okay? And that's the other thing. It could be more than one part. It's not like, oh, both parts were true, so therefore it's not true. No, it is. It's an or statement, so one part needs to be true. All right. Okay. In the next example, we have a couple of examples here that are and or equations. All right. So if we take a look at the first one, add 6 to both sides, we get 3x equals 18. Divide both sides by 3, we get x equals 6. On the right side, if we add 6 to both sides, we get 5x equals 30 and x equals 6. And we have this and statement in the middle. So x equals 6 and x equals 6, that's all good, right? We got the same answer for both. That means x equals 6 is our answer. That's a good thing. So again, as long as both parts are true, x equals 6 and x equals 6, you're good. Let's look at maybe the bottom one. Let's actually jump down here for a moment. If we solve the one on the left, we already did that up top here, we get x equals 6. If we solve this other one on the right, we get x equals 8. We have an and statement between them. X equals 6 and x equals 8. Well, that doesn't make sense. You can't have x equals 6 and x equal 8. That means that this is not a true statement. This is not true. You can't have it equal two different things and say and in between them. But if we look at number 2, it's an or statement. It's the same equation we had in number 3. It's an or statement. X equals 6 or x equals 8. That's fine. You can leave your answer like that. As long as one of those parts is true, then you're good. Okay. Let's look at it here. This is where, honestly, and or statements don't really go with equations. They really go with inequalities. We're going to look more at compound inequalities than we do compound equations. It's one of those things. Eureka kind of goes into the equations, but the reality is we are going to be looking more at inequalities when we're talking about and versus or. So when we're talking about an and statement, we're saying that x is going to be less than 3. Okay. And x is going to be greater than 1. I like to use negative 1. I like to use different colored pens for this. I think it helps. So if you notice, the numbers that are going to work here are the numbers that are between -1 and 3. it has to be greater than -1 and less than 3 in order to be an answer to this problem. So for example, a number between them would be 0. 0 would work. 4 would not work because even though 4 is greater than -1, it's not less than 3. It has to work for both of them. So with and statements, this is something you want to write down, star, and everything else. With and statements, you're looking for the overlap. When you shade on the number line, you want to see where is it overlapping. That's what you want for an and statement. So where does it overlap? It overlaps between -1 and 3. And something like 4 would not work. What about 3? Does 3 work as an answer? No, because it's not less than 3. If that was x is less than or equal to 3, then that would be good because it would work for both of them. So whatever numbers you talk about as solutions has to work for both parts of that statement. Okay, let's look at another example. An or statement, on the other hand, you're going to see in a moment, is anything that is shaded counts as an answer. So if we look at this number line, and let's do the first one in pink, greater than 4, okay? Or less than or equal to 0. So equal to is a closed circle going to the left. Any number that is shaded, any number that is in that or in one of those two categories works as an answer. So a number like 5, that works. As long as it works for one of them, it is considered to be true. A number like -1 would work because it's less than 0. A number like 3 would not work because it doesn't work for either of those statements. So when we're talking about an or statement, we're looking at anything at all that is shaded. So again, with or statements, it has to be any number that is shaded. With an and statement, it's the overlap. Those are the two main takeaways I want you to have when we're talking about and or statements. And again, we're going to focus mostly in on inequalities. It's not really, sometimes we'll have an inequality and an equation, but we'll rarely have two equations like we did on that one slide. Let's look at another example. So this is an example where you have, the inequality and equation. So if we look at g is greater than -2, or g is equal to -2. So I'm going to just shade in that circle. I mean, it's equal to. That's how I show that. Solid in circle. So it's anything at all. And if it helps, I'll use a different color pen too. So that's how I did it, right? It's anything at all that is shaded because it's an or statement works. So does -2 work as a solution? It does. Does -3? No. Does 0? Yes. Does 100? Yes. Any number that is shaded is going to work. Okay. Next example. Or statement. We have 2 greater than 2 or greater than 6. So you might have thought from the previous examples that, hey, it's always going to be, shaded towards each other, whatever. Don't fall into that trap. You just graph each of them separately. And in this example, it's an or statement. So it's anything at all that is shaded. So I can actually summarize this one up a little bit as it's any number greater than 2. Because everything above 6 falls into that category. Anything that is shaded is going to be an answer. So the reality is I can actually write my answer as a simplified answer of m is greater than 2. In the last one, it's another or statement. So we're looking for, anything at all that is shaded because it's or. So it's greater than -5 or less than or equal to 2. So what's shaded? Everything. Everything on this number line is shaded. So therefore, anything at all that is shaded, this will be all real numbers. So that's going to be the key thing with compound inequalities, is it's not just taking that and graphing it, it's then interpreting what the graph is telling you. That's going to be the key. So that's what we're going to work on a lot in class, is interpreting graphs. Interpreting graphs, wow. blanked on spelling there. Interpreting graphs is going to be the key thing to telling us what our simplified answer will be. And that's what we're going to work on a lot in class. And this will be something that we work on for probably 2 days in class. This is not a lesson that I would rush through because it can take a little bit of time to really get down. But I want you to have this introduction, see how to graph it, and then understand the difference between and or. With an and statement, you're looking for anything that's overlapping in the shaded area. With an or statement, it's anything that is shaded. All right. Thank you.